Guys, Jepril here with another physics problems. So, first things first, the quality of my videos have improved because I now have better budget for it. Like, I can now afford a template for PowerPoint, which is pretty nice. And yeah, let's move on with the first problem. So, first problem is exercise 17.24. Now, the situation goes like this. In an effort to stay awake for an all-night study session, a student makes a cup of coffee by placing a 200-watt electric immersion heater in 0.320 kilograms of water. How much heat must be added to the water to raise its temperature from 20 degrees Celsius, which is probably room temperature, to 80 degrees Celsius? And how much time is required? Assume that all of the heater's power goes into heating the water. So, So the reason why I chose this problem is because it's relevant to most students. Like, of course, we try to stay awake from an all-night study session. And yeah, so the given are mass, which is 0.320 kg, temperature 1, which is 20 degrees Celsius, and temperature 2, which is 80 degrees Celsius, and the specific heat of water, which is either given or which is something you have to search for, which is 4190 joules per kilogram degree Celsius. And lastly, the power, which is relevant for the second equation, which is 200 watts, or to make it easier for us to understand where to put it, 200 joules per second. Now we're trying to find heat, which is Q, and time, which is T. So the solutions for the first one. So heat is equivalent to mass times specific heat times change in temperature. So we have to find the change in temp. We have to find for the change in temperature first before we can solve for Q. Now, change in temperature is simply T2 minus T1, which is 80 degrees Celsius minus 20 degrees Celsius, which is 60 degrees Celsius. So plug that in. Q is equals to 0.320 kg times 4190 joules per kilogram degree Celsius and 60 degrees Celsius. So the kilogram in degrees Celsius gets cancelled out, and the only thing left is joules, which is 80,448 joules. Next is power. Now, it's important to understand that power is in joules per second, and we're trying to find time on equation B. With that said, in order to cancel time, you have to cancel joules, so a logical thing here is to put Q on top and power on the bottom. So, 80,448 over 400. This cancels the joules and only leaves the seconds, which is 402.24 seconds, or 6 minutes and 42 seconds. Let's move on to the next problem. How much heat is required to convert 18 grams of ice at negative 10 degrees Celsius to steam at 100 degrees Celsius? So, express your answers in joules, calories, and BTU. Now, this is an important problem because this teaches us about conversion. Now, heat. So, heat is gained in order to make the ice 100 degrees Celsius. So let's find out. So mass is 18 grams, or convert it to kilograms for unit consistency, 0.018 kg. Specific heat of water is 4190 joules per kilogram degree Celsius. And temperature 1 is 100 degrees and temperature 2 is negative 10 degrees. So latent heat of fusion of water is 334 joules, or 79.7 calories per gram, or simply 334,000 joules per kilogram joules per kilogram. So we're trying to convert 18 grams of ice into steam, so latent heat of fusion is really needed. Now, Q removed is equals to MC change of T minus MLF. So what we're trying to find is the heat minus the latent heat of fusion to find Q removed, because Q gain is equals to Q removed. Now we have to solve for change of T. Change of T is simply negative 10 degrees minus 100, since initial temperature is negative 10 and final temp since initial temperature is negative 10, final temperature is 100, which gives us negative 100. And now let's do it. Let's plug it in. 0.320 kg times 4190 joules per kilogram degrees Celsius times negative 110 degrees Celsius minus 0.332 times 0.32 kg times 334,000 joules per kg. That cancels out kg, and you're left with joules on both sides, which is, if you equate the first one, which is mc change of T, you get negative 147,488 minus 106,880 joules, and you get 254,368. Now, it's negative 254,368 because we're trying to find the amount of heat that has to be removed from a 100 degrees Celsius of steam to make it at negative 10 degrees Celsius of ice. We're using latent heat of fusion because its state of matter has been converted from steam to ice. Now, let's move on to the last problem of this problem, which is the second to the last problem. It's converting it to calories. So 1 calorie is equals to 4.186 joules. So just plug it in. 1 calories over 4.186 joules. Just cancel out joules and you get 60,766 calories. To BTU, you got 1 BTU is equals to 1055 joules. So just plug it in. 1 BTU over 1055 times 254,368 and you get 241.11 BTU. Now let's move on to the last problem. A laboratory technician drops an 0.0850 kg sample of unknown solid material at 100 degrees Celsius into a calorimeter. The calorimeter can, initially at 19 degrees Celsius, is made out of 0.150 kg of copper and contains 0.200 kg of water. The final temperature of the calorimeter can contents is 26.1 degrees Celsius. Compute the specific heat of the sample. So we're trying to find specific heat of the unknown material. Now we're given the mass of the material 0.0850 kg, mass of the material copper, which is 0.0150 kg, and mass of water, which is m water, which is 0.200 kg. Now we're given T1 for the material, which is 100 degrees Celsius, T1 from the can, which is 19 degrees Celsius, and the T2 for everything, which is 26.1 degrees Celsius. So the higher temperature loses heat in this scenario, and the lower temperature gains heat. So 19 degrees Celsius was converted to 26.1, and 100 degrees Celsius was converted to 26.1. Now, specific heat of water is equals to 4,190 joules per kilogram degrees Celsius. Specific heat of copper is 390 joules per kilogram degrees Celsius. So with that said, we can now find the specific heat of the material. So the equation, Q can plus Q water plus Q material is equals to 0, just simply the conservation of energy. This means that heat loss is equals to heat gained. Now, Q is equals to mc change of T. So if we plug that in, the Q for can is, its mass is 0.15, its specific heat is 390, and its change in temperature is 26.1 minus 19. So that's the Q of can, plus 200 kg times 4190 times 26.1 minus 19 degrees Celsius, and that's the Q of water. Now plus 0.850 kg times C of material times 26.1 minus 100 degrees Celsius is equals to 0. So first things first, the value of the Q of material is gonna be negative because it actually gained heat. Now, if we put that to the other side and divide it by 0.850 kg and its change in temperature, we can get the CF material, which is simply just adding the two values Q cam plus Q water and dividing it by the mass and change in temperature of the material, and you get the CF material. C material is equals to 1014 joules per kilogram degrees Celsius. And that's all the physics problems I have for now. For now. For now. I still got physics problems. This is just 15% of my grades. Good night.